So we did talk about there's only one number from this entire 2A table that we actually need. The only number we actually need is the number of what? Females that are ages 40 to 44, because that's all that we were dealing with. So that's our N. The P that we are dealing with and defining is the proportion of all females aged 40 to 44 who are patients at this HMO, which is defined as HMO, that contracted this particular mild illness in the past year with 95% confidence. Questions on that? Make sure you're being very wording specific. I have this one that's zoomed in more so y'all can see it a little bit, but I know you can't see the whole thing because when I'm in Paint, I can't pick my percent. So just make sure you're paying attention to wording. It was very specific that it was just in the past year. Contract the illness. It's only women or females aged 40 to 44 from this HMO. And we're defining success as they contracted this particular mild illness. All right, so method should be fairly easy right now because there are only one if we know its proportions. What told you that it was a proportion problem? It literally says the word proportion. So again, just like from before, you should not have an issue differentiating between mean and proportion. The weird thing about this problem is it gave us something a little bit different than we have dealt with. It gave us the what different, which was kind of the one we just dealt with a second ago. But before today, we hadn't dealt with this way. How did it give you P hat? It gave us a percent for the P hat instead of an X over an N, which isn't always the case. You'll some get, it's kind of a mix of both. So normal, it's stated normal sample or stated random sample. So that's random selection. You need to specify random selection when we're dealing with random there. Normal, our N was 370, which was the only thing we found from the chart. So N times P hat is 37. N times 1 minus P hat is 333. So realize if you use the calculator to do this one, like the way I told you before, you would have needed to find this 37 first. So you would be typing in 37 out of 370 if you did it through the test in the calculator. And then in words, there are at least 10 females aged 40 to 44 who are patients at the HMO that both did and did not contract this particular mild illness in the past year. So we can use normal approximation. So make sure you have P hats, not just P here. Make sure you wrote so we can use normal approximation, and make sure that you wrote the sentence off to the side. Independent 10% condition. Again, I've been happy with this pretty much all the way through. Some people start to get lazy and forget to write 10% condition or just kind of forget to think about it. So you need the word independent and the words 10% condition. We get 3,700 here. So assuming there are at least 3,700 female ages 40 to 44 who are patients at this HMO. And then this just comes down to work. Make sure you show your process as P hat plus or minus Z times square root of P hat, 1 minus P hat over N. Confidence level for 95% is a Z of 1.96. So that should give you a lower bound of about 0.0694 and an upper bound of 0.1306. In talking about that, let's say I get an answer, like I'm doing this proportion problem, I'm not really thinking about what I'm doing, and I get I'm solving for proportion. Do I see any red flags with this aside from like context? Like, would that be a bad answer for proportion? For a regular proportion, is there anything wrong there? We'll talk about a different one. Would there be anything wrong with this one? Because what are our proportions between? 0 and 1. Now, could we technically have a confidence interval that goes proportion outside of 0 to 1? Yes, because it's saying everything that way. But red flag, don't see any big red flags here. But if I made it specific to the problem that we're dealing with, it is a red flag. Why is that an issue? So our p hat here is 10%. So at least take 2 seconds to look and say, is this number less than 10% and this number bigger than 10%? And they should be equally apart. You'll catch some of your careless mistakes by doing stuff like that. But here, this is a little bit, this one's about 5 less, about 4 less. This is about 3% less, about 3% more. That looks good. It's centered around 10. So you can catch your mistakes by looking at stuff like that. Part B, I didn't really need to talk about right now, but I wanted to bring it up because it is very, very, very clear that you guys do not know what, if you even know that there are 2 different interpret equations. There are 2 interpret equations. One of them is confidence interval. Confidence interval interpret always goes where? Where do you always write your confidence interval interpret sentence? As your what? Conclude. Confidence level interpret is only when it's asked for, and it doesn't ever talk about your lower bound and upper bound. It just talks about the percent. So this is 95% of all possible samples of 370 females age 40 to 44 patients at this HMO would result in an interval that actually captures our true parameter. So make sure that you know what that is, because on the quiz, a lot of people did not yet.
What confused me was, how did you get the Z word?
The bottom of your purple chart.
Yeah, but I know that. So I thought we used the sample. Like,
so if you're finding a Z, then the only thing, that's a T chart. So Z on that chart is cheating by the very bottom line being infinity.
I'm sorry, what?